Hello, my name is John Kelly and this is the Weber Auto YouTube channel. Today we will be looking at the hybrid electric rear drive axle that has been used as part of the 2006 and above Toyota Highlander all-wheel drive systems and the new 2016 and above Toyota RAV4. This is an electric motor driven rear axle. There is no drive shaft that connects to this. It just has three big wires that come in from a special inverter converter assembly under the hood that controls three electric motors rather than two. Now the three electric motors that are part of the Highlander and the RAV4, we have two that are in the transaxle itself. Now this is the P300 transaxle. It was used in 2006 through 2011 Toyota Highlanders. It was also used in the Lexus RX Hybrid 2006 through 2008, and then different variations of this transaxle that just had different gear ratios, different torque ratings of the electric motors, but functions exactly the same, just different size gears, different heavy duty, light duty versions of this transaxle have the two electric motors. We have MG2 that propels the vehicle down the road, and then we have MG1 that is the starter generator assembly. It starts the internal combustion engine and it acts as a generator, and it is used with what's called a power split device planetary gear set to vary the amount of engine torque that is delivered to help MG2 propel the vehicle down the road by turning the counter drive gear, counter driven gear, and the final drive. Now the model number of this rear axle is the Q211, the Q211 rear axle, and it has a 3-digit code on it right here of a 2FM. Now, as we've talked about in the series on the evolution of the Toyota Prius, these 3 digits mean something. The 2 typically indicates the generation of this model. So this is a second generation rear axle, but this is what came in a 2006 and above Toyota Highlander. So you might think, well, where's the first generation? Because in the United States, the 2006 Toyota Highlander was the first that had this Q211 rear axle in it. Well, in Japan, they had a minivan that had a rear axle and a CVT, a hybrid electric CVT in the front. And I'm thinking, although I don't know for sure, and if any of you know, please comment in the box below, that it would have been a 1 here on the earlier versions. And then the F, they have the letters A through F, and they keep going on transaxles that are different versions of that same model. This is F. That's the 6th. A, B, C, D, E, F. Yeah, that's the 6th version of this. And then the M, I believe, stands for it's an electric motor driven axle. All right, well, the rear drive axle here has a single electric motor. It's called motor generator rear, or MGR, and it's underneath this cover here. We have, let's see, this is the front of the vehicle right here. So these would be axle shafts going to the driver's side rear and the passenger side rear here on the other side. As you can see, there are 3 holes right here for the 3-phase cables coming in from the inverter converter assembly underneath the hood. This is a air-cooled, as you can see these fins here, all kinds of cooling fins, air-cooled electric motor housing. You can see more fins underneath over here. There's no liquid cooling, no oil to fluid heat exchanger. It's just the transmission fluid that's in here, which by the way is the Toyota world standard fluid, and that absorbs the heat from the stator and the MGR rotor assembly, transfers it to the housing where it radiates out into the air off of these cooling fins. So don't spray these with undercoating, and if they get all coated with mud, it could get plugged up and overheated. Now, I owned a brand new 2008 Toyota Highlander for many years, and it said right in the owner's manual that this is an all-wheel drive vehicle. This is not an off-road four-wheel drive vehicle. Although Toyota, on the back of the original Highlander and on the new RAV4, calls it a four-wheel drive -I. And the -I stands for intelligent. The I is intelligent. And it basically has three modes of operation. There's a startup mode where your vehicle just starts to move, and it, at least on my Highlander, and from what I've read in the other service information on the RAV4 and the newer Highlanders, is it will provide a little bit of torque always upon takeoff. And on my Highlander, it seemed like it was always from about 0 to 3 miles an hour, that it gave torque to the rear wheels and helped the front wheel drive portion of the Highlander or RAV4 move down the road. And that was just in case there was slick surfaces or loose gravel or whatever. And then during normal driving, it's not applying torque to the rear axles at all, unless it detects an impending slip, like a front wheel is slipping or about to slip. Then it would apply torque to the right and left axle shafts to help push the front wheels out of their slipping condition. And the third mode is regenerative braking. So every time you slow down, it can contribute electrical current to the inverter converter assembly, where it's changed to DC and fed back to recharge the high voltage battery. Now, on the Highlanders, the high voltage battery was 288 volts. On the RAV4, the new RAV4 2016 and above, it's 244.8 volts. But it can contribute and help slow the vehicle as long as the state of charge of the battery is low enough that it can accept that. All right, well, let's take a look at the case here. Now, I have an empty case. I have the pieces laid out here on the bench, and we'll put it together most of the way here in this video. But this is the driver's side. Here's the front. On the driver's side here, there's this big, heavy cast iron MAST damper. The function of this is to add some additional weight. It's just a big, heavy weight to the housing here and stop certain or change the frequency of a vibration that could occur on these. We've got a plug here on the side, where if you watched any of my other videos on the Toyota, the evolution of the Toyota Prius transaxle, this plug is to reach in at the factory and adjust the resolver assembly that's underneath this cover. And the resolver assembly is what keeps track of the position of the electric motor, its rotational speed, and the direction of rotation. Normally, that's not a plug you would ever remove. That is not a fluid fill plug or a fluid check plug. Then we have two electrical connectors up here on the driver's side. This front one here is for the resolver. It connects to the resolver. This other one is for the temperature sensor of the stator assembly inside of here. Now, as we come around front here, we have the vent of this rear axle. We have a fluid fill plug that, of course, in the vehicle you wouldn't be able to get to it, so there's another plug you can put fluid in, but that is a fluid fill plug. On the passenger side, we have the three-phase cable connections here, and then we also have, if you look, the fluid drain plug right here and the fluid level check plug right here. So the fluid level check plug is where you take this plug out, as long as the vehicle's on a level surface. If fluid comes out, then it was overfilled. If no fluid comes out, you need to add some until it does, and then let it slow to a steady drip, and then put the plug back in. All right, on the back we just have some mounting brackets. This is a 3-piece case. We have the cover here where the resolver, the stator, and the electric motor are, and then on this side we have where all the gears, the final drive, the counter drive gear, and the motor drive gear are all housed in this case here. So let's separate the case halves. I have all the bolts removed, all the fluid drained, all the parts are out of here. There's some, got to be real careful here so we don't break the electrical connections. But there's some pry points like right here and right over here where we can pry up. There's some dowel pins. We can pry right where the dowel pin is on the outside of the dowel pin. We want to pry up as evenly as we can. We want to avoid just sticking it in on any machine surface and trying to pry it up. But right here where the dowel pin is, slowly, oh, there we go. Okay. All right, so here's the inside of the case half where the gears sit. The final drive is going to sit right in here, and a counter gear and the electric motor drive gear. We have some oil catch basins here. The final drive gear is going to sling oil up and fill up these areas here, and then there's holes where it drips down and lubricates the bearings. On this side, on this side of the case, the center case, the final drive gear is going to be spinning this way, fling oil up into these catch basins. It also sends oil through to the other side where it drips down on the stator assembly to help cool it, and onto the electric motor rotor to help cool it. All right, so let's take off this cover here. There's a pry point right here. And sometimes the pry points are in real nice, easy to get locations. Other times they don't make any sense at all to me as to why the pry point's there rather than someplace else. Here we go. So here is the driver's side case cover. We have the resolver assembly. That resolver assembly is held on with 3 bolts from the back. It is one that needs to be calibrated out of the factory, so do not undo those bolts unless you absolutely have to. And if you absolutely have to, make sure you make alignment marks on the resolver versus the case, so that it goes back in the same location. And then we have the empty case area here where the stator, the rotor, the pass-through connector for the 3-phase windings all fit right here. Okay, well, let's put this thing together. All right, the first thing that needs to go in is the pass-through connector right here for the 3-phase cables. The pass-through connector goes all the way through the width of this center case here and sticks partially, not quite all the way through, but sticks most of the way through to where when we bolt up the 3-phase cable connection here, it makes a good electrical connection with the pass-through connector. And then we've just got a couple of bolts that hold that in place. All right, the next thing that goes in is our stator assembly. The stator assembly right here has a built-in temperature sensor that will need to plug into this empty electrical connector right here that goes right here on the stator case cover portion once we get that assembled. But now let's put the stator in the housing. There we go. All right, we've got our 3 long stator bolts. We've got to look through and make sure those holes are lined up. I think it is. All right, next we have 3 bolts that hold the 3-phase cables for the stator to the electrical pass-through. When we put these together, they need to be good and clean. If we were putting this together to really go back in the vehicle today, I would clean those off with contact cleaner, have them good and dry, have the threads dry, the bolt threads dry, the receptacle threads dry, and make sure that we have a good electrical connection so that we don't have any type of a voltage drop occurring, robbing power from the stator. All right, so we've got our, other than torquing the bolts, we've got our stator assembly installed. We've got our stator temperature sensor that's going to plug in to the cover, as I said, that will go right here. But we are not going to put that cover on in this video, so I'm just going to tuck this off to the side here for a moment, and let's set this out of the way, and let's look at the other case half where the gears go. Now, in order to allow this case half to sit level as we assemble it, I'm going to put a couple of extra long bolts in here to stabilize it. There we go. All right. Okay, the first part that's going to go in here with the gears is our MGR drive gear. Now, this drive gear connects to the rotor for the MGR motor, and it's going to turn this drive gear right here. It has a ball bearing right here that fits right down into the case, just like that. And then we have a counter gear. The counter gear has some teeth right here. It has 40 teeth on the counter gear, and let's see, 18 teeth on the pinion drive gear right here. So that will go in next. The gear ratio for the MGR drive gear to the counter shaft is 1.739 to 1. We have 23 teeth on the drive gear, 40 teeth on the counter gear, so it takes a little less than 1 3/4 turns of the MGR drive shaft gear here, or drive gear, to get 1 rotation of the counter gear. Then we have the final drive assembly. This final drive assembly is pretty light duty. It doesn't have to handle a lot of torque. It just has to assist the front tires, the front axle, in pushing the vehicle forward when there's a loss of traction. So this is not an off-road four-wheel drive system. Notice it only has 6 bolts holding the ring gear to the differential case. It's just a little tiny differential case. It has a little tiny open style differential. So we'll take our final drive gear here and differential case, set it in place, and then we'll take our little axle shaft here, stub shaft, and stick it in for some support. The final drive gear here has 71 teeth on the ring gear and 18 teeth on the little pinion on the top of the counter transfer gear, which gives us a 3.944 to 1 gear ratio between the counter gear and the final drive gear. And we already know we have a 1.739 gear ratio between the MGR drive gear and the counter gear. So if you multiply those two gear ratios together, you get an overall gear ratio of 6.859 to 1. It's going to take 6.859 turns of the electric motor to get 1 rotation of the differential case, which is the same speed as the tires. So now we'll bring in the electric motor. This electric motor here, as you can see, is rated for 50 kilowatt, which is 67 horsepower. That's in addition to what is in the front transaxle. It has an additional 130 newton meters of torque, or 96 pound-feet of torque, and that's going to sit right on the splines of the counter, or of the MGR drive gear. There we go, just like that. So as the electric motor rotates, here's the forward vehicle movement direction of rotation. It's going to take 6.859 rotations of this electric motor to get 1 rotation of the tire. Now, how does that compare to the front transaxle electric motor, MG2? Well, MG2 on this same vehicle has to rotate 8.878 times for 1 rotation of the front tires. And this is 6.859, so it actually turns slower than MG2 does driving the vehicle up front. It gives us 96 pound-feet of torque, but we can multiply that by 6.859, which gives us a total of 659 pound-feet of torque in addition to what the front transaxle delivers, which is on the Lexus model 2160 pound-feet of torque, on the Toyota model 1913 pound-feet of torque. So a combined of 25 to 2700 pound-feet of torque delivered to the tires, which is the most powerful front-wheel drive hybrid system that Toyota has. Now, there's more powerful rear-wheel drives in the Lexus, but for front-wheel drives, this system here, that a variation but a little bit lower power, is used in the new RAV4 for 2016 and above, but some pretty high amount of power for a 7-passenger vehicle, the Toyota Highlander Hybrid, since 2006, which is pretty impressive. By the way, the Lexus RX and the Toyota Highlander use the same transaxle, but the Lexus got a 3.5 to 1 gear reduction final drive, where the Toyota's got a 3.154. They have the exact same engines. Everything else in the transaxle is exactly the same. But since the Lexus has more gear reduction, it will accelerate a little more quickly, have a little more torque, but at the expense of a little worse fuel economy. All right, well, this setup right here, where we have a motor driving a countershaft, driving a final drive, is basically what you have in almost every electric vehicle on the road, except the difference would be how big is this electric motor, how much power does it have, and if you make it more powerful, these gears need to be thicker and stronger, the bearings need to be bigger, and so on. But it's just a 3-shaft system. The shaft that has the electric motor, the countershaft for the gear reduction and torque multiplication, and then the final drive with the differential in it to allow the tires to turn different speeds while you turn corners. So this is the Q211 rear axle setup on Toyota Highlander and RAV4 vehicles. From what I've read, this has been used in the rear axle of Japan versions of Toyota Priuses. And as I mentioned at the start of the video, there's a Toyota van made in Japan that had a rear electric axle. I do not know if it's this one. I suspect it is. Along with a CVT transmission and a hybrid electric motor sandwiched between the engine and the CVT transmission, much like the Honda integrated motor assist system over there. So it was a different style of hybrid electric van. So this is the Q211 rear axle. Let me just quickly slide it out of the way for a moment. Let's just look real quickly here at the P300 series that is used in all the other Toyota hybrid vehicles besides the Prius. The Prius does not use this. It uses a smaller, lighter weight version called the P410, or there's others, P510, 610. There's even a new P710 that's coming out in the 2018 Toyota Camry hybrid. That's much like the P610 transaxle. It just is bigger to handle more torque. But and I believe that P710 transaxle is going to phase out this P300 series transaxle, because prior to 2018 Camry hybrid, it used a P314 transaxle that was just like this, but with different power, a smaller power rating, different gear ratios for the final drive, but all P300. So there's this is a P310. It was replaced by a P313. The original Toyota Camry hybrid had a P311. And then the Nissan Altima hybrid had a P312. There's a P314 now that has replaced the P311 that the Camry had. And now the P314 is used in the Avalon hybrid, the RAV4 hybrid, Camry hybrid, the 2017 hybrid Highlander still uses the P313, but they are all just like this. And if you want to know how this system works and see the internal components and all of that, look up the P410 deep dive transaxle video that I made, because it's just like this, except everything's just a little bit smaller. So on the all-wheel drive systems that are out there with Toyota, or the four-wheel drive -i, the intelligent four-wheel drive systems, it's a two-motor front hybrid transaxle with a single motor rear axle with no drive shaft. It's just electric front and electric rear axle, and these two motors propel the vehicle down the road. All three of them can give you regenerative braking when you slow down. If you put your transmission shifter in the B position, the braking mode, then it will use the power from MG1 here, motor generator number 1, also in regenerative braking to help slow you down, which gives you additional braking that you normally would not have. All right, well, this has been a review and look at the Q211 rear axle and the Toyota four-wheel drive and all-wheel drive systems on hybrid electric vehicles. Thank you for watching.